Okay.
Okay, now it's clear.
All right, I'll start right away. Good afternoon, everyone. So, so in this conference, as Mr. Ahmad already said, title of our research is Regression Models Analysis in Predicting the Impact of Population Growth on Flood Intensity in Jakarta. The paper is written by me, myself, Adriel Darmawan, Nathanael Boentoro, Kevin Christian Surya, and Derwin Suhartono. And unfortunately, Mr. Derwin is unable to present for today, but we will carry out the presentation for today. So can we move on to the next slide, please? Okay, so for the contents, there'll be background and then literature review, methodology, results and discussion, and end it with a conclusion. Next. So now for the background. Next. Okay. Jakarta, as we know, it is a heavily populated area. So therefore, it is very vulnerable to many environmental issues. And the reason that it is a big portion of population uses groundwater as their main source of daily water consumption. So that this constant absorption of groundwater causes the land subsidence, and this will of course lead to flooding. And as the land becomes more inundated. Take 2020, for example, a massive flood happened in Jakarta right after the New Year, if you remember. And then this flood should be taken seriously by all the citizens of Jakarta because they themselves contribute to the result. And as any other issue, we would like to look for a solution in getting rid of the problem. One of the many methods that we can use is doing a prediction or forecasting. In doing this prediction task, we specifically used mathematical models known as the regression models. And then next slide, yes, for the literature review. Next slide again, please. Okay. So this is, as we know, linear regression is an algorithm that describes the relation between a dependent variable and independent variable. As we can see, we have the formula here. And then we also have multiple linear regression, where here the number of n describes the number of the number of independent variables in the equation. And then we also have polynomial regression. So in the polynomial regression, the number of n describes the degree of the polynomial equation. Next slide, please. Okay. So both simple linear regression and MLR are mainly used as the methods of data analysis in IoT environment using machine learning. And they both known for good speed and effective as well. However, it is not very accurate most of the times. So there are other regression that are more accurate, like polynomial regression and decision tree regression. So that is for the regression. Go back. Yeah, wait a minute, please. And then since we want to study about the flood intensity, we'll also look for a research in that specific area. But since we didn't really found any similar research about talking about flood intensity, so we took this formula from a research. So it is using rainfall intensity, but we modified it a little bit. And the modification will be explained further by my partner in the next part. Thank you. Next slide, please. Okay.
Okay, so the next part here, we'll talk about our methodology. So for our methodology, we start by gathering data, and then we pre-process the data, split the data, and finally we model the data. Okay, the next slide. Okay, so for the data set, we have two kinds of data. Those are population data and flood data. So we collected this data from these websites. So population data here contains Jakarta's population from 1950 to 2019 and the population projection until 2035. Meanwhile, the flood data contains average flood height, the duration of the puddle, and the number of missing people, casualties, and other entities that are affected by the flood in each month from 2013 to 2019. These data are already in Excel file, so we can easily process them in using Google Colab. So after we collected the data, we did some pre-processing to clean up the data. So as you can see here in the top right, the data format between 2013 data and 2019 data aren't the same. So we convert the 2019 data into 2013 data format to easy up the pre-processing part. And then we also change not available values to 0. And during the process, we also identified outliers, which are 2015 and 2016 population data. We handled these outliers by adjusting them to the mean of the data. And then next one is pre-processing. Oh, this one is dataset. Yeah, dataset splitting. We use the datasets here. The first dataset, which consists of 80% train and 20 test sets. And the second dataset consists of 100 test sets and 100% train sets. This kind of splitting could be uncommon, but the reason we did this is because we are lacking data, because there are only like for 8 datas, I think. Yeah, and then the next one is feature selection. Yeah, so out of all the attributes, we extracted the total population attribute and flood intensity, which was calculated using the formula that was mentioned in the literature review before. And to test whether the features are appropriate as the predictors in regression, we used correlation matrix, and the result was satisfying enough with 0.82 correlation. Yeah, and then after that, so after we get everything we need, last step is modeling. All of our models are built in Python, so it is not that hard to make them, as there are lots of libraries to support them. So yeah, we created 4 kinds of models. We have OLS, or ordinary least square, or it is a simple linear regression. We have univariate and multivariate, with affected people as the additional predictors for the multivariate OLS. Then we have polynomial regression with the 3rd degree, because through our experiment, the 3rd degree gives the best accuracy. And the 3rd model is trace regression with 1000 iterations and learning rate of 10 to the power of -4. And the last one is decision tree. And for the evaluation metrics, we used MAA, MSE, and R-square score.
Okay, now we are going to talk about the result and the discussion. So this is the OLS, the first data set. So as we can see, this is the graph, and besides that, there is the evaluation matrix that is consists of R-square squad, MAE, MMC. And then next is the second data set. This is the graph and the evaluation matrix. So if we see that there is a slight difference between the first data set and second data set, and by see the evaluation matrix, the OLS is suitable in this project. And then next, we are going to talk about the multivariate linear regression. So this is the first and the second data set. And as you can see that the result isn't really quite good in the first data set. So it isn't suitable to be used in this project. So next is the polynomial regression. So this is the graph, and and besides that, there is the evaluation matrix. And the next is the second data set of the polynomial regression. There is the graph and the evaluation matrix, and as you can see, the result is quite good. So it is recommended to be used in this project. Then the next is the risk regression. This is the first data set. So this is the graph and the regression matrix. And then the next is the second data set of the risk regression. And as you can see that the result is similar to the OLS, but it has the more worse evaluation metrics. The next is the decision tree, and this is the graph and the evaluation metrics of the first data set. And then the next is the result of the second data set of the data of the decision tree. And the result, as you can see, is quite good. So it also recommended to be used in this project. So this is the all of the result. So we can see that the result of the multivariate isn't really good, so it is not recommended to be used. And the polynomial and decision tree has the good result, so it is recommended to be used in this project. So this is our discussion. So from the 4 regression model that has been experimented, the polynomial and the decision tree are the best model to predict the flight intensity that is based on the population growth and the inflow intensity, and has the accuracy in above 90%. So what's our conclusion? So our conclusion is polynomial and decision tree regression is suitable to analyze the population growth impact prediction. And also in the future, this method can be used in the similar research. So if there's maybe someone that wants to use to have a similar project, it also can be used this method. So that's all from our team. Thank you for your attention.